We're just a little bit delayed because we're waiting for a group of students to finish a tour at the Center for Functional Nanomaterials. But I want to welcome Wyandanch High School and Uniondale High School, which will be coming shortly, to our Boucher Speaker Series. The Boucher Speaker Series is named after Alexander Edward Boucher, who was the first African American to earn a PhD in the United States. And can anyone guess what his PhD was in? Yes. How did you guess that? You just knew. Okay. So actually, yeah, the first African American PhD was in physics. So he was a scientist, and so that's who this series is named after. So today's speaker is Professor Kimani Toussaint, Jr. He's a professor in the School of Engineering at Brown University with appointments in electrical and computer engineering, biomedical engineering, and mechanical engineering. Prior to joining Brown, Dr. Toussaint was on the faculty at the University of Illinois, Urbana-Champaign, and was there for 12 years, where he rose to the rank of professor in the Department of Material Science and Engineering.
Mechanical
Science and Engineering, my bad. Dr. Toussaint directs the Laboratory for Photonics Research of Bio-Nano Environments, Probe Lab, an interdisciplinary research group which focuses on both developing nonlinear optical imaging techniques for quantitative assessment of biological tissues and novel methods for harnessing plasmonic nanostructures for light-driven control of matter. He is a recipient of a 2010 NSF Career Award, the 2014 to 2015 Dr. Martin Luther King Jr. Visiting Associate Professor at MIT, the 2015 Illinois Dean's Award for Excellence in Research, the 2017 Illinois Everett Award for Teaching Excellence, and the 2019 Distinguished Promotion Award. Dr. Toussaint is also a fellow of the OSA, the Optical Society of America, and SPIE, and senior member in the IEEE. In addition, he served as the PI and inaugural director of the U.S. National Science Foundation Nanomanufacturing Node at the University of Illinois at Urbana-Champaign from 2017 to 2019. So without further ado, please welcome Professor Toussaint.
Thank you. Thank you. Well, it's a real pleasure to be here. I'm very thankful that you all were able to make it out. It's a big honor for me to be speaking, especially for Black History Month for this Edward Boucher series. Abram told me I'm only the second speaker here. This series just started last year, and I know who Edward Boucher was, so it's really a big deal. And I also remember being a student in high school. Right, so in coming up with this talk, I made it different from what I normally would do when I speak to other professors or other college students, but I thought it might be useful to talk to you all about maybe my path and how I got here, and I actually had to sit and think about that, something that I take for granted sometimes. It's somewhat informal, so if you feel the need to raise your hand and ask a question, by all means, definitely do that. So I'm now at Brown University, and I'll tell you a little bit about that later. And I have a few slides about my research itself, but I thought it might be interesting to sort of start when I was young, as a kid. I had to call my mom last night to get baby photos. I'd never call her for baby photos, right? So she said, where are you now? What are you going to be talking about? I said, okay. I'm going to talk a little bit about growing up. So I'm from Philadelphia originally, and this is, I guess, it's been 15 years since I've been on the East Coast, because I've been in the Midwest for the last 15 years, Chicago, and then somewhere called Champaign, Urbana. So I, was a kid, and I had lots of interest as a kid, doing kid stuff. And just interacting with the world, right? But one of the things that was interesting to me was gadgets, and looking at things and taking them apart and putting them back together again. 99% of the time, I was successful only in one of those things, taking it apart. Always had problems putting it back together again. But it was something now looking back on it, it's kind of, I guess, what helped spark my interest into doing what I do now. What's fascinating is, when you're a kid, someone, I didn't ask my mom how old I was in this picture, maybe 4, 5, 6, I don't know. But when you're a kid, the world is open to you in terms of how you see it. So if you ask me, what I wanted to be, who I wanted to be back then, depending on the day of the week. I might say I want to be an astronaut. For the longest time, I wanted to be a superhero. Read a lot of comics, so I also wanted to be a comic book artist. I wanted to travel the world. And, I really wanted to create stuff. I have an 8-year-old boy, and he's always talking about making a flying car, right? And I did the same thing. I was like, I want to build something that flies and do all these kind of wild stuff. So at the time, these toys were considered high tech. This is something that many of you would not necessarily know about, called an 8-track. The older people than you here would know. This was pre-tapes, regular tapes, pre-CDs, pre-MP3s. But it was an interactive robot that basically taught you things, math, interest in science things. This is something that now is retro. They brought this back, the Speak and Spell. I just got one for my son a couple of weeks ago. And this is, to help you with your spelling. And this is the Rubik's Cube, which everyone I'm sure knows about. Whether or not people play with it now is a different story. But these were all things that I took apart at one point, right? And so I thought it was interesting to think about that. So, I think I was able to put back the robot, but it didn't work anymore. The Speak and Spell, I took it apart after it stopped working. And the Rubik's Cube, I got frustrated not being able to get all the colors on there, so I just took it apart, right? And the reason why I say that, now at universities and colleges, people are reviewing how they teach math, how they teach physics, how they teach chemistry. And there's a recognition that something experience-based, how one interacts with physics, how one interacts with the chemical world, helps you learn the material better, right? And for a lot of us, when we're younger, this is the types of things that come somewhat natural. So if I were to ask you, for the high school students in here, to think back to when you were 7 years old. I'm assuming you're older than 7 now. So think back when you were 7 years old and ask yourself the question, well, what did you want to be when you grew up, right? Anyone remember? Everyone thought about it at some point. Anyone remember?
A teacher.
You wanted to be a teacher.
Doctor.
A doctor.
Teacher.
Teacher.
Chef.
Chef? Wow.
Lawyer.
Lawyer.
I was switching
Between?
everything. Doctor, lawyer, lawyer.
Miss? Don't remember.
Mechanic.
Mechanic.
A NASCAR driver.
A NASCAR driver. Wow.
Physician. Physician.
Physician. How many of y'all still want to do that? Let me see by raise of hands. How many of you all know what you want to do in 10 years, 15 years?
Oh, say it?
Yeah.
Gynecologist.
Gynecologist,
Mechanical engineer.
mechanical engineer. Either one.
Oh, lawyer still.
Lawyer still.
I don't know.
Don't know.
No clue.
No clue, right? And so this was like my normal path, right? So start off wanting to do kind of everything because I thought everything was possible. Right? I didn't think I couldn't do everything. Somewhere along the lines, things start to get a little fuzzy as to what's possible, right? So this story I'll tell you about and sort of how my decision process went about and led me to where I am now. And not knowing what you want to do is by far the most common thing the most usual thing, because I did not know what I wanted to do ultimately as I got older, right? And it's one of those things that I kind of stumbled on, and I'll discuss that with you as well, okay? So, as I grew up in Philadelphia, I eventually found myself, hello? I eventually found myself at Overbrook High School in Philadelphia, right? So Overbrook was a school about 45 minutes from my neighborhood. It wasn't my neighborhood school, but it was one of those things when you're a kid, your parents are like, okay, you should go to that school because they got this program that's good. And that's what happened. So I wound up going to that school because they had a college magnet program. And it's crazy now thinking about it, but the school in and of itself was not necessarily trying to teach everybody what they needed to go to college, right? Whereas maybe now, maybe more high schools are doing that. So there was a part of the program which was sort of like general education, where a lot of my friends were. And there was another part of the program which was just like being an artist. Some more of my friends were in there. And there was a small part of the program that was about folks who want to go to college. And for that college part, you would take a calculus class, you would take a science class, and then you would work with your counselor to try to apply for colleges to go to universities. Overbrook sort of was famous because they had a lot of famous athletes, now famous athletes, who went to the school. Everyone know Will Chamberlain. I actually was a high school junior or senior when he came back and we retired his jersey. I mean, the guy was like that. You know, his hands were like that big. And it was just crazy. Large crowds that he drew. First African-American astronaut, guy in Bluford, went to Overbrook High School. Never met him, but we knew about him. This guy you'll know. So I went to school with his younger brother, Harry, but this before he was, he blew up. And I remember even being in the calc class junior year and looking out the window and you would see Will Smith, right? This is right before, he was still the Fresh Prince, right? So this is now, I'm dating myself, 80s hip hop, right? So he was the Fresh Prince of, not Bel Air, just the Fresh Prince and DJ Jazzy Jeff. And then eventually, we heard about him getting his own TV show around the Fresh Prince. And this is before hip-hop artists, this is before hip-hop, it was rappers, got into doing anything on television, right? It's before even Yo MTV Raps, music videos, etc. So that was a big deal, right? And then me, right? So this is one of the pictures I hadn't seen since I was a kid. So my mom sent me this last night. I was like, oh my God, right? With the Georgia Tech jacket, right? So Overbrook had an interest in history. And when I was there, it was about 99% African American, and it's still that way now. In the 70s, it was more diverse in that way. When I was there, we were just at the cusp of being a high school where that was very aspirational, fighting other influences around it. So by the time I graduated, my sister went there 2 years later, and they had metal detectors everywhere, right? So Overbrook today looks fairly different from the way Overbrook used to look. I was top in my class. I didn't really apply myself when I was a freshman because I didn't feel as though I had to. I was just interested in a lot of things. By my sophomore year, it was sort of a challenge from one of my teachers, a social studies teacher. He thought I can do better. And so, okay, do better. And I wound up getting A's in all my classes from sophomore year till senior year. And that same teacher and my folks were talking to me about college. At that time, I was thinking, well, maybe I'll try to travel the world or something because I really wanted to travel. They're like, well, think about that later. Why don't you just go to college first? I said, okay, well, what am I going to do in college? I think I want to do this engineering thing or physics. We'll see what happens. So I'm from Philadelphia, the school that was sort of in my backyard was University of Pennsylvania. So I applied to Penn, got into Penn on a fellowship. And what's interesting is, high school was a place where, I applied myself, I studied, and I did well, but you don't know what you don't know until you're exposed to something that shows you what you don't know, right? And that's one of the biggest differences when you start college, right? Figuring out what those culture shocks are. So, this was like a typical high school class for me, 30, maybe 40 students in the class. By the time I got into my first calculus class, first math class, it was like 200 people, right? And for me, I'm like, okay, that's crazy, 200 people in the class. And what was even crazier, it was people raising their hands all the time. So I'm looking around, I was like, I don't have any questions, right? But people always found questions to raise their hand. First day of class, there were a line of kids ready to speak to the professor with questions. I'm like, wow. So I'm all the way in the back in the class. There was another piece of this that was also different for me. I coming from Philadelphia, a school like Penn, diversity looks different from the rest of Philly. I went from an environment that was more or less homogenous, where I can turn around and look and see people that look like me, to an environment where I was like the only one. Another big culture shock, right? So imagine now, I'm trying to study like physics, science, figure out what I want to do. And in those classes, I'm really the only one. Right, so one of the biggest challenges for me was, how do I fit in? How do people take questions that I have? And, can I do this? So my first week, I guess pop quizzes were normal back then. So like first week, Physics 101, the professor gives a pop quiz. And I don't remember the exact score, but I didn't pass the quiz, right? And here I'm coming from Overbrook. I'm like, I'm always like doing well and whatnot. And I went to go see him, and I was like, I didn't pass the quiz. I don't know what to do. What happened? I'm always passing and whatnot. He was like, well, maybe you should think about going to a different field. So I'm like, wow. Now, the one thing I had going for me, even though I hadn't figured out how exactly this hustle worked, the one thing I had going for me was I was very stubborn. Right? So what that means is that if somebody told me I couldn't do something, that meant I was going to definitely try to do it. Right? And it was somewhat of a Philly thing, personality-wise. And I kind of brought that with me. So I just had to figure out how to do it. The challenge I had was that it was very much an uphill battle. Another big difference. I was in college prep classes, for high school. These were our textbooks. These were my exact textbooks. Okay, so these are called Schaum's outlines. This is applied physics and chemistry. We covered maybe 20% of the book, of these books. They're each about 200, 250 pages, right? And I was like, okay, I know this book. I know each one of these topics, right? Freshman class, starting off at Penn, these are the books we were working with. This book alone is 600 pages, right? It's more than the sum of these other two books, right? And what was crazy was that the people I was in the class with, some of them already had this book when they were in high school, right? So as an engineer, when we solve problems, we're trying to figure out, how a car moves, how an engine works, or how a light beam should propagate. So I study optics. one of the things you talk about in engineering a lot of times is something called initial conditions, right? If I have a hill, I have a ball, I know the shape of the ball, I know the conditions of the inclined plane for that hill, I can set the initial conditions and use equations to predict where the ball will be. Okay, that's all classical physics, right? So my initial conditions, I realized, were very different from the initial conditions of everyone else I was in school with, right? So the gap after my first few weeks in school between what I knew and what my classmates knew kept getting wider and wider and wider and wider. Okay, so you can imagine how stressful that could be. Now, what's interesting is that there were opportunities that presented itself, again, because of me being stubborn, to help defray some of those issues, right? So I had mentors. A mentor, Larry Gladney, he was a professor. He was like the only African-American, certainly physics professor, scientist probably at Penn at that time. He just recently moved to Yale, Dean of Diversity as of January of this year. And I remember talking to him about me struggling and trying to figure out what's going on because I'm constantly studying, but I'm just not doing well in my classes. Right? And by this time, I had lots of interests. So I was trying to study a little bit of anthropology, archaeology, maybe because of the Indiana Jones movies, I don't know. Like I said, I wanted to travel. I also just started studying African-American history and African-American studies. And I remember having friends who were like, well, you're already African-American. Why do you need to study African-American history? Well, we study American history, don't we? And we're really American, right? So there was a lot that I was learning there that was actually useful in giving me some additional context to think that it wasn't an issue about me not having the capability of doing well, right? It was really an issue that had more to do with the initial conditions being different and me learning about how this whole system works. So Gladney, like many professors that I have since come to understand, had a variety of programs over the summer. And I took advantage of every single one of them, right? So I knew I liked taking things apart. I knew I liked science. I knew I liked engineering. I knew I liked that part of that world. But I wanted to get the experience. So I remember my freshman summer, he had a robotics project. And obviously this is not the robot that we worked on, but he had a robotics project based around what's now the defunded, was never built, superconducting super collider in Texas. And I knew nothing about robots, but he had an engineer there who was willing to work with us, freshmen, to teach us how to program and do things to make a robot move, right? It was the best thing in my life. The next summer, an even cooler project, he was working with NASA to put up, right before you go into space, is something called suborbital, a balloon gondola that would have a telescope to detect certain types of radiation. So we would get to go spend a week at a NASA base, build this telescope, put it on this balloon, and it would get launched up, right? Now, at that time, I remember it was sophomore summer. It was in Virginia, Wallops Island, Virginia. And I remember it was strange that every single television at that base of NASA was on the Weather Channel, right? But when you're there and you're trying to launch something into space, the weather has to cooperate. So we would go for a week, sit around, not launch anything, because the weather wasn't cooperating. And so we have to go back home. And then they'll call us to go back again. So there was a lot of back and forth that I realized then was the reality of launching satellites, right? But in the end, we launched it. It detected data. At the time, Professor Gladney told us about 2 innovations that he said would change our lives for that project. One, it was something called a web browser, right? It was, at that time, this is before Chrome and Safari, so this was Netscape, right? A web browser. He said, I'm telling you, this is going to be a big deal. Physicists could communicate with each other. We're like, all right, but, Also, on the wings of the satellite, there was something else he said was a big deal. It was about this big. And he said it's called a global positioning system, GPS. I'm like, okay. He said this can tell wherever you are in the world. I'm like, all right. And so it's funny, I remind him of that today. He gave me my first exposure. Our cell phones have all this stuff today, and we take it for granted. But he gave me my first exposure, freshman year, sophomore year, doing this work, right? And so what was nice about that was that whatever was going on with me in classes, I knew I can do the work. I just had to connect the dots, okay? Then, there was another guy. He was a laser spectroscopist, someone who uses light to study materials. Arjun Yod, still a professor at Penn. And there was a program that was funded by the National Science Foundation. And so when you're in college, when you're done with classes during the regular school year, summertime comes. And you'll find out that everyone is hustling to try to figure out how to get paid over the summer. And there are a million programs, but you got to know about those programs, right? So for me, I was always trying to hustle to figure out how can I get paid to do some work that I loved. And I remember Yod had this, he was part of this program that would pay students something like $3,000 to work in a lab. And that's a lot of money, especially when you're like a sophomore, junior, and whatnot. Trick was you had to have a high GPA. I was like, okay, well, that's going to be a problem. But I approached him. I told him, you don't know me, but I'm a hard worker. I haven't quite figured out this class thing yet. But if you hire me, if you give me an opportunity, I promise you I will work hard, I will learn the material. So, okay. Fine. He did that, gave me my first exposures to working with lasers. He put me on a project where I had to build something called a monochromator to look at different wavelengths of light being emitted from, let's say, an object, right? Then, by junior year, things started turning around. I started getting a better footing because of these activities. And there was another professor I had. He's passed now. He was actually a chemist, Anthony Garrido. And Garrido didn't give me any summer opportunities. I never talked to him about that. But I took a class with him on a totally different topic in physics and thermodynamics. And at the end of every class, he would just sit with me and answer like my science questions. He was like the science guy. And he was always passionate about talking about optics. And he would say, Kimani, here's why optics is important. Yes, we can make lasers, but here are the ways in which we can interact with the world. Here's how we can use it for communications. Here's how we can use it for medicine, right? And you should think about pursuing a career in optics. So by this time, I'm approaching senior year, I'm trying to figure out what I want to do. He's talking about something called photonics. And I'm like, okay, what's this photonics thing? Turns out photonics is to study an application of light, much like you have electronics. And I'm like, all right, I'm going to look into it. And that's exactly what I did, right? So I found my footing, not in the first year, not in the second year, towards the end of the third year. And once I found my footing, things started to click because of these activities, because of these mentoring that I had. And I applied to Boston University. Now, I'm from Philly, right? And there's an intrinsic dislike in Philadelphia of Boston. Okay? When I was growing up, it was the Sixers, You know, I remember Dr. J getting in a fight with Larry Bird for the Celtics, and I was like, there's no way I'm going to Boston, right? And people who knew me was like, there's no way Kimani's going to Boston. But they had built this very expensive center in the late 90s focused on photonics. And you can come in, get a master's degree, train in an engineering topic of your choice, whether or not you have that background, and then go off and work in a national lab or start a company. So I said, all right, that sounds good. It's a short time. I don't have to be in school forever. And I can go ahead and do this thing on photonics that Professor Garita was telling me about. So 2 years turned into 3 years, which eventually became 7 years, because I didn't stop with the master's, even though I thought I was going to stop at the master's, but I was really finding my footing. And one of the things that was interesting to me, that whole alienation feeling that I had, being the only one, by the time I got to grad school, I became comfortable inserting myself pretty much in any environment. Right? It didn't matter where people were from, whether they were from America, whether from other countries. I got really comfortable at it. And I found there was so much for me to learn from everybody. So there were people working on problem sets for the physics class I was taking or for the chemistry work that I was doing that I was completely missing out on when I first started college. And I realized all of this, you know, eventually. I didn't know all this in the beginning. So once I started having a lot of allies, a lot of friends across the board, the material I was working on started coming in more naturally, right? And there was a lab that was doing work that was inspired by something that Einstein didn't think would really happen. He kind of put it out there as a thought experiment. And it was called the Quantum Imaging Lab. And we were looking at something called quantum entanglement, right? So if anybody's watched anything at all with science fiction, at some point and whatnot, you would come up with entanglement. So you can imagine having a particle, having two particles. You have two particles in the process, right? Let them be photons, let them be electrons, doesn't matter. But you have two particles. What Einstein said, if entanglement was a real thing, was that one should be able to manipulate the properties of one particle. I'm going to measure the color of that particle. And once I measure the color of that particle, now this is the realm of quantum physics, as opposed to classical physics. The other particle I'm going to send to the other side of the universe, literally, somehow. And once I go ahead and do that, that other particle now instantaneously takes on a color, right? That's related to the measurement that you did on the particle that's in this room. And Einstein had a problem with that because he said, well, that means the information from particle 1 to particle 2 must have traveled faster than the speed of light. And Einstein was already famous for theories that show that nothing can travel faster than the speed of light, right? That's that process of entanglement. Turns out it's been explained more or less as to what it's not. And I was in electrical engineering, and we found ways of being able to generate those particles. And we wanted to use those particles to measure stuff. Right? So here now, I grew up on comics. I like science fiction, like taking things apart, like doing stuff in my hands. Here was an opportunity to do something that I was really genuinely interested in. And what you're looking at here is this ring of colors is the actual light. If I take any pair of those colors, they actually wind up being entangled. And we wanted to go ahead and make a device out of that. And this was the device, a schematic of the device that I built for my PhD, right? And at that time, I remember not thinking I was really going to be one of those people who stayed in school forever to get a PhD. but it was something that eventually made sense to me. And this light source goes through some measuring devices, or preparation devices rather. It interacts with a sample. The sample could be a silicon disc, a piece of gold. And we have some other measuring devices, and we have detector 1 and detector 2. So you have 2 photons that are generated by this light source, and one goes and interacts with the sample, and the other one goes off into this other direction. This can be infinitely far apart. All the stuff that happens here is felt here. That's what entanglement does, right? And what was cool, this gave me my first patent. No one had done it before. No one had built it up before. No one had the theory for it before. And it was my project, right? And I thought that was the most amazing thing for me as a student to be able to get a patent. But I'll tell you, that entire process of getting this to work, that entire process, like I said, it took me ultimately about 7 years, even though the PhD part of it was 5. That entire process was stressful. It was stressful because by the time you get to a certain point in school where you're doing something like this for a PhD, you have to do it because you're passionate about it. Because most of the time it doesn't work. And anyone who does any types of experiments, you're trying to build stuff, you realize most of the time stuff doesn't work. And so I had to develop a mentoring community. So people who will help get my back, people who will help me figure out how to stay in the program, because you have thoughts about leaving the program. And these were all people who just did something different for me along the way. This guy here is an aerospace mechanical engineer, right, and an ex-Marine. Very unorthodox, very interesting life story. This guy, former physicist who's like a computer scientist now. This woman here was the first African-American woman to graduate with a PhD from MIT, right? She's now at Maryland. This guy, he was the first person to give me an opportunity at Boston University to work in his lab. Does stuff in magnetic data storage. Nothing to do with really with what I was interested in. Some of you I know at the lab would know Professor Ntingwa. I met him through her. She is a dean, not even a scientist per se, at MIT. I met her through my mother, because my mom knew her mom, right? And when I'm struggling, I'm calling up, because you got to have friends, you got to have family that you talk to. I said, well, Mom, you know, I don't know about doing all this. She said, did you reach out to Blanche yet? I said, no, I haven't reached out to Blanche. She doesn't do anything with optics, or you should reach out to Blanche. So eventually, I reached out to this very nice person, and I wasn't at MIT, but she acted like I was at MIT. And she was constantly sending me information, one of which was to introduce me to this guy. And this guy helped take me to different places in Africa to give talks and interact with scientists on the continent. Small world. It's really amazing, right? And I'll get back to something else she did in a minute. This guy was the first African-American president of the Optical Society of America. And I remember going to conferences, and I bumped into him and introduced myself. Each one of these people I maintained regular contact with while I was in school, because they each were able to offer me something that I wasn't getting from my class or wasn't even getting from my PhD advisors. One of the things that happened towards my last year, I was trying to figure out what I wanted to do. So all that schooling, all those years, and I still wasn't 100% sure what I wanted to do. I knew the superhero thing wasn't exactly practical, unless I was a billionaire like Tony Stark, make myself an Iron Man armor. Doing the artist thing was nothing that I kept up with, so that wasn't necessarily a practical thing. But I was very interested potentially in doing this thing as a teacher. And the challenge was, my professors were not good cheerleaders for becoming professors, right? Why would I want to be a professor? right? I knew I wanted to do something where I had control of my own time. I wasn't exactly a suit and tie person. I liked being in the lab. I liked interacting with other students. What are the occupations that allow me to do that? Dean Staten told me about a program at Georgia Tech. He said, Kimani, have you heard about this program at Georgia Tech, the Focus program? I said, no, right? And she said, you should apply for it. They'll bring you in, if you get in, for a couple of days. And when you're in, they'll take you through mock interviews and teach you about what professors do. So, all right, I'll do that. I applied, I got in. It's like 6 of us in it. Did exactly that. By the time I came back, my girlfriend then, wife now, I was like, this professor thing's a hustle. I can do this. She's like, you really want to go become a professor? I said, yeah, because I can see how I can make it work for me. And I can see how it can fulfill my need to kind of work for myself. Right? But I knew to be able to get to the level that I wanted to do, I needed a little bit more exposure, a little bit more experience. So, when all my friends were out getting nice jobs, getting paid, I still went and got a pay cut by being a postdoc at University of Chicago, where I was there for about 3 years, working for a physical chemist, a chemistry professor, but I got exposed to more stuff. And in particular, I got exposed to the idea of building my own microscope that can do things that regular microscopes can't do. I got exposed to nanotechnology and what that was all about, and particularly working with metallic nanoparticles and manipulating them. And I got exposed to making light do some strange things. So this is a picture of a light beam. But unlike the laser pointer, where you see this green beam is just a roundish beam that does not have a hole in it, you can make light have a hole in it. A donut beam is what the fancy term we call it. And this donut beam has very special properties when you couple it in to the microscope. And these are things that I learned. I learned how to do. I was able to write papers about it. And so now, when I decided to go ahead full force and apply to become a professor, I started off at the University of Illinois, which was 2 hours south of Chicago. All right, this is the Urbana-Champaign campus. So, not many of you may have heard of Urbana-Champaign. If you all in Big Ten, watch any college sports, you may have heard about the Illini. Champaign-Urbana is not Chicago. Okay, it's not New York, right? It may not even be Brookhaven. Okay, there's 100,000 people, mostly college, lots of farmland. Right? So what that means is that you got plenty of time to do work. Not much time for much else. And believe it or not, for a young professor starting off, that's the best thing, because now you spend all your time focusing on developing your research. And the engineering program there is top 10, so it was very good. And so I was able to launch a career in optics, doing what I love, with lasers, building up microscopes. And I'll tell you a little bit about that in a few slides. And last September, after 12 years at Illinois, I moved to a new place in Providence, Brown University, where I'm rebuilding my lab, have new colleagues, new exposure, new things where I'm sort of venturing into. So a question could be, well, what is light? What is optics? Right? I mentioned that I am in optics. Right? It obviously has stuff to do with light. So anything to do with the generation, propagation, and detection of light is broadly put under optics. If you're in the medical field, you may not think of optics this way. You may think about the person who works on your vision. Right? That's an optics person as well. Right? Just works on the vision optics, perception stuff. The term is almost equal to the term photonics, and is almost equal to the term just light, right? Now, what I always ask my students when you're starting off and you're trying to learn something about light and what it's about, I always ask them this question, well, what do you think of optics? What do you think about light in pop culture, right? And these are some of the things that come up, right? So the Death Star and the beam, the lightsaber, teleportation somehow comes up in that. And interestingly enough, it is a phenomenon. And even being transparent or non-corporeal, being able to walk through things. These are all things that over the years students told me came up when they thought about sort of optics in pop culture. Okay? Now what's interesting, if I show you some things for optics in real life, it's moving towards the direction of pop culture. Right? So here is someone trying to make an invisibility cloak. Yeah, if you're curious, I'll tell you more about how that works. First demonstration of long-distance quantum teleportation. That was done a couple of years ago in China, from Earth-based to a satellite-based system, as well as this idea of being able to bend light and do cloaking. So this one's a really simple experiment. And I had a student build this up for me last year for a class. Basically a pair of lenses. You just have to have the right distances between the lenses. And all that's happening here is that the rays are bending around, right, based on those focal lengths.
Professor Toussaint,
Yep.
excuse me, I'm sorry, I just have to interrupt. Wyandanch has to leave a little bit early, so if I can get Wyandanch students to stand and
Oh.
exit this way, please. Thank you.
Well, it was
Sorry
nice
about
meeting you all. Bye.
Please continue.
All right. So, in a nutshell, we'll find that optics in real life is starting to move towards the type of optics that you'll see in pop culture, right? Becoming more sci-fi, in part because some of the people working on this stuff grew up watching some of the science fiction things, and they want to see these things happen, right? So my lab focused on doing things for nano, using light, nanophotonics, and for bioimaging, using light, okay? In the nano realm, we worked, I'll put these up, with something called optical antennas, right? So everyone knows what an antenna is, right? And the antennas that you normally would see, I'm assuming, are big antennas. So when I was growing up, television sets at the time, pre-cable, were ones where you would have these rabbit ear antennas, right? And you move them around, right? And at that time, you know, it was necessary because we had like 3, maybe 10 channels. And the cartoons came on something called UHF. Everything else came on VHF, right? But the length of the antenna tells you something about the wavelength of the light that it interacts with, right? So an antenna is a device that converts, this is called a transducer, it converts energy of one type into energy of another type. In particular, it can take energy that's propagating through the air, like light energy, radio frequency energy, and funnel it down to localize energy on a chip. Okay? Now, when you want to deal with light in the visible part of the spectrum, red, orange, yellow, green, blue, violet, then the size of the antenna shrinks. Because now the wavelength of the light is no longer millimeters, for instance. It is nanometers. That's very small. And so you need special techniques to make these structures, right? And so that's what we do in my lab. So we have gold, and gold at nanoscales is a little different from what you have from gold from a necklace or from watch or something like that. It has very interesting properties. If I shine light on a gold watch, it comes back the way you expect it to be. Looks like gold. But if I did something crazy and took a machine and broke up that gold watch and shine light, and I kept breaking up into smaller and smaller and smaller pieces, and then shine the light on it, it's no longer going to look like the gold you see. It may look green. It may look red, right? Because the properties now are different because it's interacting with the atoms around it in a different way. And what's interesting as an engineer is that we can make gold antennas, put them in an array, so you have thousands of them on top of glass, and then make them amplify forces associated with light. So if I told you the stuff on Star Trek, that I can use light to move objects, like, wow, that sounds amazing. Right? The Nobel Prize in Physics recently went to someone who demonstrated that a while back, something called optical tweezers. The trick is that the laser beam has to interact with particles that are the right size. So if I shine a laser beam on you, it's actually pushing on you. But you're not going to feel it. Okay? It has something called radiation pressure. But if the particle or the object is the size of 10% of the thickness of the average strand of hair, where that would normally be 50 micrometers, 100 micrometers, we start moving to like 10 micrometers, maybe even 1 micrometer. And then now we put that particle in, let's say, water, and I shine light on it. The light will push the particle. And if you want to manipulate it so that it's not just pushing it, you want to move it around anywhere in space, you can use a microscope to do that. And I mentioned to you I do stuff with microscopes. So we found ways of being able to make light do that using our special particles, special nano antennas, whereby we have our nano chip. We're looking at a microscope. We have these really small particles, hundreds of nanometers to a couple of microns, a couple of micrometers, and we're shining a laser beam that you can't see. So on the other side of this, through the microscope, this is all in water. And what we're doing is we're moving the laser beam in a circle, and the particle is following the laser beam. Right? And we can not only do that with a single particle, but we can do that now with a swarm of particles, where we had about 50 particles in that swarm, and we are moving them across this nanochip, right, with power that's less than the power that you have from this laser pointer, which is amazing, right? And sometimes you just don't want regular particles. You want particles that give off light, maybe because you're doing some type of biological imaging, and they give off something called fluorescence. And it turns out the antennas can also not just be used to amplify optical forces, but they amplify how light interacts with the objects around it. So this is an example here where you have a particle that gives off light, and when you put that particle onto the antenna chip, the light that's emitted by the particle gets brighter, using the same enhancement effect. So for years we spent time building up all the cool things that we can do with these antennas. We found out that, I know everybody nowadays is, everyone is digital cameras because it's in the cell phones. But the old-fashioned cameras use old-fashioned film. And I remember taking a class where I would go into a dark room and learn how to develop the film. Well, this, under the right conditions, can act like film and record information from light. And we showed how to do that. We showed that we can write on a nano chip. Yeah, I was at the University of Illinois. The symbol is, guess what? An eye. And so we can write in real time. The development gets done in real time. This whole thing is the chip. And the reason why it's doing this is because the heating properties change under the right conditions when I shine light on it. So the amount of color it gives back and the types of color it gives back will be different. We can use something like a projector and make even like a short nano movie. Right? And my son says he thinks someone dancing, right? But the idea was to be someone walking. And you can even do that, I don't know if this will work, where you show, let's see. Sorry, I couldn't get this to work here. But you can also do that to record music. Right? And those of you who are curious about it, this was something that I had to look into. Like I wondered how they went from silent pictures way back when to talking movies, long before they developed lasers, long before they developed chips, transistors, right? And we use the same ideas to encode information onto this chip and then read that information out with a camera and translate that into sound. And it works beautifully, right? But in addition to all the nano work, we do work with biological imaging. And so if I were to shine light on your skin and look at it under a microscope, right, I will have problems telling the fibers in your skin from everything else. I need to enhance the contrast, the difference between the stuff that I'm looking at and the background. And it turns out that certain biological materials give off light if you shine light on it under the right conditions. So if I took something that's a beam much more powerful than this, and I pulsed it, so I turned it on and off really quickly, gave it a relatively large intensity, and then shine it on the fibers in your skin. The fiber is called collagen. Then what happens is that the collagen fibers will change the color of the light. So the red light then becomes green, for example. And you can get very high contrast images. You can see the fibers in 3 dimensions. Whoops. And you can study their properties. Right? And again, this is all around the microscope. You can apply this to looking at cancer. So we're interested, and what we've worked with are people who are in biology, people who are maybe even in the medical field, to try to understand their problems better so we can make technologies that would help them, right? And we did the same thing, applying this to looking at the problem of preterm birth, looking at the cervix, using this type of technology. Now, sometimes I still pinch myself because I remember very much the trajectory that I started off with and where I am today. And one of the most flattering things is to be able to get recognition from other people in your discipline that you've made some contributions, right? So a couple of years, I was recognized by that optical society, there's a couple of optical societies, for the contributions that I've made in nano-optics, in imaging, and so forth. But what's even cooler is that you get to travel, right? What, professors don't, most professors don't really become rich, right? But we do okay, right? So, but one of the benefits of it is that we control our time and we get to go around talking about what we love because people invite us to come speak about our work. And I've had the opportunity to be to South Africa a couple of times to talk about my work through that earlier person, Sakazi and Tingra, Cairo to talk about my work. So I finally got to see the pyramids, and that was just awesome. Went inside and crawled inside the pyramid. Russia, Yeah, before all the drama, when I was a student, luckily. Ecuador, recently. Sometimes I can bring my family on these trips. China, right? And these are just trips that were based on my work, right? And which I think is one of the most fantastic gifts for this type of job. So, in conclusion, one thing I'll tell you is that one of the things I've had the opportunity to do as a professor is speak to students who are just starting college. Most of those students who are starting college don't know what they want to do. Right? There are a couple of them who have their whole lives planned out. Right? I fell into the first category. Right? I had a sense of what I wanted to do when I was really young. I wanted to do everything. Then that became a little bit fuzzy, particularly with the challenges that came with it. And then I had opportunities in mentoring, and I sort of found my footing along the way, right? So I want to reiterate that what's nice is that you get exposure. What was the big thing for me was I had exposure to different areas, in this particular case of areas of science. I got a good sense of what I liked. I got a better sense of what I did not like. And along the way, I developed sort of just this committees of mentors, people who got used to me bugging them, right? Because there was a lot of things I just didn't know, right? And those things, those people helped shape my career. As I mentioned earlier, when I was younger, I said I wanted to do all this traveling. I get to do the traveling now, right? And you get to meet people from all over the world to talk about your work. You get to invent things, right? And so to me, this has been an incredible journey. And I am so lucky to be able to have taken this. So I want to thank Brookhaven for inviting me here. I want to thank Dr. Abram Ledbetter for specifically inviting me here. And it's really cool, but if you all get an opportunity, read up a little bit about Edward Boucher. Dr. Ledbetter mentioned already, he got his PhD in physics at Yale like in 1870s. Right, this is like 10 years after slavery officially ended. Okay? He was one of the first 20 or so people in America to have a PhD in physics. Right? So it's really amazing, the types of accomplishments he made. So I think this does justice in terms of having this society, this speaker series named after him. All right, so thank you. I will open the floor for questions.
Okay, we have about 5 minutes for questions. I'll take 3. Yes, Noel.
So you indicated between high school and college, undergraduate and graduate school, you had a phobia or a concern about asking questions.
Yep.
Could you share with us some strategies or what clicked for you to overcome this fear
Sure.
to ask questions
Sure.
openly in public when the environment wasn't in favor
Sure.
of you?
Sure. Ultimately, what happened was that basically my confidence started to build up the more exposure I got to doing like hands-on work. I knew I was as smart as everyone else, but reconciling them and truly knowing that I was as smart as everyone else took some time. And so I would say it probably wasn't really into graduate school that I became super comfortable. Some questions I asked were great, some maybe not so much. But you know what? I figured I would start getting everyone used to me asking questions. And as much as you think you learn from having a professor get in front of the class or a teacher get in front of the class and just start lecturing, you don't really learn until you really start asking questions. There is a process of interaction that allows you to really absorb information. If you're just sitting there copying notes, and then you regurgitate those notes in the form of an exam, trust me, you're going to forget it. But if you keep asking, and you don't care if people laugh, because in a good class they shouldn't laugh, you keep asking, you keep making the mistakes, then what happens is you start getting used to your own voice. You start hearing yourself ask these technical questions, and you realize these are just as good questions as anybody else. And it took a while, but I had fundamentally to believe that I was as good at doing the work as everybody else. And that's the thing that made a big difference. Because if you don't believe that, then the battle's done. You have to believe it.
2 more questions, students? Okay.
How did you do in that physics class?
The last one with the thermal professor, I got an A. It's my only A that I got in that physics, in any of those physics classes. It's my only one. And what was amazing was how easy the material came. And this is related to Noel's question. That professor believed in me, right? And he would use me as an example. Say, I love Kimani's question. It was one of those things where it's amazing how far that goes. I didn't know how to necessarily process all that at the time, but looking back on it, when someone believes in you, it makes it easier for you to believe in yourself. And it was one of those things, I never got to tell him all this or anything like that, but it was one of those things looking back on it, I mean, it was like a game changer. Because I decided to go into optics. I decided I would give this graduate school thing a try. And here I am today. So it was one of those things where ultimately his belief that I can be a major contributor in that field was something that made me do better. Yep.
You spoke about initial conditions.
Yes.
And just thinking about your high school self.
Yep.
Many students do very well.
Yep.
In high school and amongst their own peers within that high school, and told that they may even be the valedictorian, and then they do have that culture shock.
Yep.
And have those same experiences as you've had. But what could you tell them to help them when they're in school if they don't even know that there would be such an initial condition going into other environments, especially the Ivy League, as yourself, when they're told that they're special, they're smart, and, so what would you have told yourself even?
So when I started, I was under the impression that if I wasn't doing well, it was just because I just still wasn't putting enough time into it. And I was living in the library. I had books, I was going through material, I just wasn't putting enough time, I told myself. I didn't know there was something mechanistic about college. And I wasn't able to be this insightful until much later. The same reason I decided to become a professor after that Georgia Tech sojourn, I would go back and tell myself to recognize there is a hustle. And I use that with all love in terms of the terminology. But every discipline, whether you want to become a musician, my sister's a doctor, whether you want to become a doctor, a lawyer, every discipline has its own language and its own de facto norms and mores. Once you understand that system, how things are hustled, it's not just about you putting in 80 hours. That's a part of it, right? But you have to understand, what do other people know? What do they have access to that you may not have access to? And there was a world of things I did not have access to that I didn't know I didn't have access to. That's what you call ignorance, right? It wasn't until those opportunities where I was in the lab and I started interacting more with those students, and I really honed this by the time I got to graduate school. There was all this information and how to approach topics that made a world of difference. So I became a lot more efficient and became really good at what I do. I already had the passion. I already had the imagination. I already had the will to do the work, right? It was the mechanisms that I didn't understand at the time. If you were on Wall Street, there's a whole nother culture there.
But your high school
Yeah, I would have told myself in high school that, to be honest, I mean, I know teachers don't normally say this, but it's a hustle. And you have to understand that hustle. So there's the formality of it. The formality is you apply, you go to your classes, you study, and you do well. But it's so much more than what's on paper than that. And the reason why that's important to understand and to recognize, because what we tend to do, especially underrepresented groups and women, is that the moment we see some adversity, I didn't do well in that chemistry class, I didn't do that well in that math class, well, I don't want to be a chemist or a mathematician. Can't do it. Just didn't do well in it. But if you start to understand that you not doing well in that class does not mean you don't have the potential to excel and make significant contributions in those fields, then you never gave yourself a chance to get in the race. So then the question then becomes, well, how is everybody else doing well? What are they doing differently? You know, what type of backgrounds are they? Like the whole thing about old exams. I had no idea about that stuff. Because I mean, that's not like something you talk about in high school. You know, you have the old exam for this class. That was like normal in college. I had to figure out who had what old exams, which teachers, which professors to take. Those are all informal rules. No university codifies that. No university puts that in writing as part of the admissions process.
Old Regents exams. Most
Yeah.
of the students don't even, or the teachers even tell them
Right.
that those things are available
Right.
readily, free.
Right. So that's what I would tell myself, you know, so that would have helped me realize where to put my energy.
Thank you.
Yep.
Let's give Professor Toussaint a round of applause.
Thank you.
He is continuing in the tradition of Boucher, who, by the way, was not only a physicist but an educator, and he wasn't able to become a professor. There were roadblocks that prevented him from doing that, but he did educate black students, and he spent his life doing that. He valued making opportunities for students like you to learn. So, once again, thank you.
No, thank you. I really appreciate it.